Hey, good morning, everybody. Let's get started. So last week we did some stuff about miscellaneous factoring techniques, and I know it's probably very challenging for you. Hopefully you did okay on it. Don't sweat it too much if it didn't land 100%, because there is one more way we can factor something. In fact, it's the most useful way and the most general way, so you don't need any tricks or anything like that. You need to be able to graph things and do some long division and things like that. And that's what we're going to learn today. So this is kind of the culmination of polynomial study. This is what we're going to lead up to, is this lesson today. Before we do that, let's go ahead and review some of the miscellaneous factoring techniques. So could you factor something if you really needed to without today's techniques? Well, let's find out if you can. So number one today is x cubed minus 7x squared minus 3x plus 21. If you got nothing to do, one thing you could try when you have four things like this, 1, 2, 3, 4, is to factor by grouping. One technique that's kind of out there, and you can think about it. To factor by grouping, you look at the first two and the last two, and you factor them separately. So the first two, if you look at this, I could factor an x squared out of them. Would you agree? So I'm going to factor an x squared out, and that will leave you with an x minus 7 remaining. The second group, you hope to factor something out and also have like an x minus 7 remaining. Now, I see that the next group has a 3 in them. That's great. If I take a 3 out, I'd be left with a negative x and a plus 7. That's not quite x minus 7. The signs are backwards. So I'm not only going to factor out a 3, but I'm also going to factor out a negative. Factor a negative and a 3 out of the next two terms. Then what remains is an x minus 7. And if you're lucky enough to do that, and you see they have the same thing in common, factoring by grouping is a great strategy. Because just like any number, if they have them in common, you can factor it out of the whole thing. So if both these have an x minus 7, you can factor the x minus 7 out of the entire expression. So it's been taken out of everything. And if you can imagine that that's gone from both of them, then the only thing left is an x squared minus 3. So that's all factored now, which is pretty darn sweet. Direction said to solve. So we need to find actually when do these things equal 0. Just one step farther than factoring, not really that much work. Once things are factored, pretty much you just set the factors equal to 0 and see what the answers are. Now this one's pretty obvious. If you set that equal to 0, the answer would be 7. X equals 7. The other one, x squared minus 3, well, we're going to have to, I don't know. I'm not quite sure what makes that 0. So go just set it equal to 0. Look at a fresh problem, and how would you solve that? I think you'd probably just move the 3 over, would you agree? Take a square root. So if you move the 3 over and take a square root, don't forget your plus or minus, then there's two answers from that little piece as well. Positive square root of 3 and negative square root of 3. And if you go back and check real quick, if this is with a third degree, then you should have 3 answers, and you do. 1, 2, 3. So everything's good, and we're all done with number 1. So there's factoring by grouping as a quick refresher. You got 4 things, maybe lump them in groups of 2, and hopefully if you factor the groups separately, they would have something in common. Okay, now number 2, here we go. We got 8x cubed equals 125. Your strategy in general should always be, for any polynomial, to set it equal to 0. Just like quadratic. You want to use quadratic formula, you got to set it equal to 0. Same thing here. So it's tempting to maybe just do something right off the bat, but no. Let's set it equal to 0 and reassess. Maybe there's something in our toolbox to factor this thing. Well, I see something cubed minus something. So the first thing that jumps in my mind is maybe this is a difference of 2 things that are cubed. Maybe. So let's try to force this thing as one thing cubed minus some other thing cubed. If I can get to write like that, then I can use my difference of cubes equation. It's also promising that's a difference of cubes because it's got the numbers 8 and 125 in it. And if you go down your list right here, perfect cubes, 8 and 125 are perfect cubes. So what cubed is 8? According to my little chart over there, 2 cubed is 8. That covers the 8. But we also got x cubed, so maybe an x. So the quantity 2x, when cubed, 2x times 2x times 2x does in fact equal 8x cubed. And from the chart, 5 cubed is 125. So we can think of this as a difference of cubes right here. And if you need to, line it up with the formula. Here's the formula for the difference of cubes. It's on the board right there. Nothing new, but here's my formula. Something cubed minus something else cubed can be factored into this stuff right here. So you got to see what things represent. When you use equations, you got to think outside the box just a tad and think, okay, well, what does A mean? A in this case is 2x, right? And b in this case would be 5. So to factor this difference of cubes, I'm going to replace this formula right here with a's are going to be 2x's and b's are going to be 5's. So replacing it with this equation right here, this says a minus b, so 2x minus 5. That's how it starts off. And then it says a squared. Well, a was 2x. And if I take the whole thing 2x and square it, square the 2 and the x, I get 4x squared for that part. Then the formula says plus ab. A was 2x and b was 5. Their product is 10x. And then lastly on the end it says plus b squared. B was 5. 5 squared is 25. So we got that factored down thanks to our difference of cubes right there. All right, well, still equal to 0. You know, never let your equation not be an equation. So if you're setting equal to 0, write equal to 0 the whole way through. Okay, how are we going to find these answers? Well, again, if it's factored, set the factors equal to 0. So if we set this equal to 0, here's a factor, 2x minus 5. If you set it equal to 0, move the 5 over and divide by 2. I won't bore you with the intermediate step. You get 5 halves right there. The other one's weird looking. I don't know, 4x squared plus 10x plus 25. I could attempt to factor it. Maybe it factors into a 2x and a 2x, something like that. But there's something we have to avoid factoring. If it's too complicated and it's just ugly, just do quadratic formula. It's a quadratic. Try to figure out when it's equal to 0. That's exactly what the quadratic formula is for. So I'm going to save myself a step and just do it. Here we go. X equals negative b. That would be negative 10. Plus or minus the square root of b squared. 10 squared is 100. Minus 4ac. So minus 4 times a. A is also 4. And c is 25. All over 2a. A was 4. And 2 times 4 is 8. So I have all 3 answers. You see them there. We just got to clean this one up a little bit. That's all we got to do. So maybe get your calculator out and clean up this discriminant a little bit. I don't know. Negative 300. Okay, negative under the root. So automatically, that's just going to be an I thing, right? So square root of 300i, it's a big number. I should try to clean my square roots if I can. Is there any perfect squares that go into 300? I'm thinking 100. 100 something squared, isn't it? So let's break this up into 100 and a leftover of 3. Because 100 times 3 is 300. And the reason you'd want to do that, of course, is because the square root of 100 is pretty. It's 10, right? So now we got negative 10 plus or minus 10. We still have this leftover square root of 3 and this I. And it's all over 8. Well, pretty good. Pretty good. Only thing I can see to improve it is we can reduce it a little bit. I see 10/8 buried in both of those. And if you reduce 10/8, you get 5/4. So in both these fractions, we can reduce it to 5/4. There we go. Negative 5 plus or minus 5 square root. So we basically took everything on top and divided by 2. Everything on bottom divided by 2. And there's our 3 answers right there. 5 halves, negative 5 plus or minus 5 square root of 3i all over 4. There are 3 answers as promised. Was a 3rd degree equation from the get-go. So you should have 3 answers, even though it might take some work and some struggle to get there. All right, lastly, we got number 3. This is the other flavor that might be thrown your way. X to the 4th minus 9x squared plus 20 equals 0. All right. Now, I don't know if you can see it or not, but this is a quadratic form. This is, whenever you have this first exponent twice the second one, you should think this can still be written as some kind of quadratic right here. Something squared minus 9 times the something plus 20. Somehow, some way, I can make this work. And it does work, provided it's x squareds instead of x's. Normally it's x's. But you can have anything in there. And this does fit the bill of a quadratic. Something squared minus 9 times the something plus 20. And if it is a quadratic form, hopefully it factors just like usual. Forget all the fanciness with the x squared and stuff like that. I'm thinking 20 on the end, 2 numbers that multiply by 20, and add to be negative 9. I'm thinking are -4 and -5. They multiply to be 20 and add to be -9. And I wouldn't put x's here because this wasn't a quadratic with x's. It was a quadratic with x squareds, right? So what goes inside of here are x squareds this time. So that's the only difference. Do it like normal. You're just doing it with x squareds instead of x's in this particular case. And now you got it down. You can probably solve from here. This actually is a difference of squares right here. We can factor this one a little bit more because 4 is something squared. 4 is 2 squared, isn't it? So we can factor this down more. Well, what's our difference of squares say? If you have something squared minus something else squared, a squared minus b squared is a plus b times a minus b. Well, in our situation right here, a would be x and b would be 2. So this thing factors into an x plus 2 and an x minus 2. And this third one, 5 is not a perfect square. So I can't do it on that one. I saw the 4. 4 is something squared. I can do that. 5 is not something squared. I'm just going to get gross with like square root of 5, but we're not going to do that. You can see 2 of the answers pop right out at you now. -2 is 1 and 2 is 1. They make the first 2 factors equal to 0. The last one, it's not perfect square, but again, pretty easy to solve this equation if you just set equal to 0 and move the 5 over. Take a square root. Don't forget your plus or minus. There's the other 2. Plus or minus square root of 5. So there's all 4 of them. It's a 4th degree equation. So I should get 4 answers. I did. -2 and 2. Positive square root of 5 and negative square root of 5. And that's kind of the whole point behind that stuff right there. So there's the factored form of that. And then we'll move right on. All right, let's do some LGs and get to the main lesson. I'm kind of excited a little bit. Here we go. Students will learn to use the factor theorem. Very powerful theorem. I didn't know the name of it until I prepped it. Oh, that's what that's called, huh? When you can factor things down.
Oh, really?
Yeah, it has a name.
Okay.
I'm like, okay. Okay. Weird. So big one today, big one. If all those little tricks bothered you, you don't have to have them. They are the fastest. You can see a difference of cubes or a sum of cubes or a difference of squares. Man, that's a lot easier to spot that and factor it that way. If you can see factoring by grouping, great, that'd be fastest. You can see something's a quadratic form, wonderful. And sometimes, once in a while, those are the only tricks you got. But there is a general thing we're going to talk about today to help you factor anything, no matter how complicated and big it is, if it can be factored. Cannot guarantee that it'll be factored. All right, here's your new homework. Write that down real quick. Homework 5.3. It's actually over section 5.4. We're skipping section 5.3. The section 5.3 is kind of pointless. I looked at it like, really don't need to do that. It's not going to help you ever in the future. Kind of silly. So we're skipping section 5.3. So this homework is over section 5.4. It's still the third assignment of the unit, though, so the homework title is still 5.3, but it's over section 5.4. 2 through 20 even. Make sure you write down the directions. Use direct substitution. It's got some other funky stuff in there. It's like do this, and you don't need to do any of that fancy stuff. Just plug something in. That's what that basically means. So they say use direct substitution. That's a fancy word for just plug the number in. Your directions for basically for that section is plug things in. You also have 23 through 44. Now, it's not due till Friday, so I plan to give you guys a couple work days on this, not because it's insanely hard, because I might be gone Thursday, and because I want you to really understand it. So you got plenty of work time on this, nothing to freak out about, and let's dive right in. Okay, so notes. Here we go. Section 5.4. It's going to be good today. Good stuff. Title of it is The Remainder and Factor Theorems. You might want to get your calculator out, too. You might want to get your calculator out. The remainder theorem is kind of pointless too, honestly. I'm going to try to cut through all the nonsense today and just tell you what's really super important. Let's get right to it. Let's do this. It's called the factor theorem. I'm not going to talk about the remainder theorem. It's so pointless. You have no problems assigned over it. Don't worry about it. This is called the factor theorem here. And I would like you to write down a couple of key vocab words. First off, this is one called depressed polynomial. It's a good word. Depressed polynomial. And depressed polynomial is written right there what it's called. It's a polynomial that has a degree that is one less than the original polynomial. Depressed polynomial. We can just, nah, I'm too depressed. I can't find the will to do it. Yeah, it's too hard. Not this week. Not this week. All right. So what's a factor theorem say? Actually, it says something that you already know. Let's say, I'm going to go back to an analogy of something far, far simpler, because this is what you're doing. I'm going to put a number on the board. Can you tell me something that goes into that? Okay, how do you know that? I put 242 on the board, or 642. And you look at it, and you got some tricks, right? It's an even number. And something you've learned from grade school is if something is even and goes into it, then 2 must go into it, right? Now, do you know what else goes into it without doing any work? Probably not. You know 2 goes into it. How you can figure out what else goes into this if you know 2 goes into it? You know 2. Oh, yeah. Well, what are you going to do in your mind? You're probably going to take this thing and divide by 2, correct? And then you're going to figure out that 321 also goes into it, right? Then what would you do? You'd look at 321 fresh, wouldn't you? And you ask yourself, does anything go into that? Is 321 easier to look at than 642? A little bit smaller, right? It's depressed. It's a little bit smaller than the original one. This is exactly what we're going to do with polynomials. We're going to find things that go into them, do some long division, and then what's left is probably going to be simpler to work with. The trick is what goes into this thing. So let's take some notes and see what we can do about this stuff. First off, I just want you to kind of write down this example, because this kind of does illustrate everything. Show that x plus 8 is a factor of this. Just like numbers, 2 goes into something. That means when I do long division, what kind of remainder should I get out? The one I just did, if I divide this by 2, I did all this work. What remainder would I get out? Anybody know? If I did all this work, what would be the remainder? It would be 0, because this goes into it, right? That's the main point of this right here. If x plus 8 goes into this thing, then when I do the long division, the remainder should be 0. That's the big highlight of today. That's one of them right there. In fact, that's what the factor theorem says. You want to write down that last thing the factor theorem said is, if something goes into it, the remainder will be 0. That's essentially the big idea. So we want to see if x plus 8 does go into this thing. So you're going to do some long division. You're going to take this big thing, 2x cubed, plus 15x squared, minus 11x, minus 24. And somebody claims that x plus 8 goes into it, so you're going to see if they're true, if they're lie or not. If this really goes into it, when I do the long division, the remainder should be, what's the magic number? 0. All right, well, let's find out if that's the case. Here we go, doing the long division. Does this go into this evenly? Let's find out. All right, well, up top, again, when you do long division, ignore everything but the leading people. X times 2x squared would give me 2x cubed. And wherever you pick up top times this whole thing, right? So that'd be 2x cubed plus 16x squared. 2x squared times 8, right? 16x squared. If you subtract them carefully, those go away. And 15 minus 16 is -1, so I have a negative x squared left over. And of course, the other junk, you bring that down too, right? So minus 11x minus 24. And then you try to go again, correct? So let's see here. X times what is negative x squared? Negative x would fit the bill there. And negative x times this whole expression would be negative x squared minus 8x. And you're going to very carefully subtract them. Negative 11 minus negative 8, that's negative 11 plus 8, which is negative 3. So negative 3x, and then you bring down the negative 24. And then you try to go again. And x times -3 would give me -3x. And -3 times this whole expression is, guess what? -3x minus 24, which when you subtract it gives you a big fat 0. So what's the moral of the story? Well, you just figured out that x plus 8 goes into this thing. And how many times does it go into it? It goes into it this many times. So what you've really done is factor. This is the whole reason we've been doing long division. The original problem of this thing cubed, when you divide it by this number, you got this, right? That means that x plus 8 times your answer is the original thing. This times this is that. And that's the whole point of this thing. If you can find something that goes into it and do some long division, you can find the other stuff that goes into it. So in a roundabout way, we started factoring this thing. Had we known x plus 8 goes into this, then I could do some long division, and I could figure out the other stuff that goes into it. And of course, we could try to factor it from there and solve it additionally. I don't know if that does factor. What does the directions say? It say solve. Nope, that's all I had to do. Okay, now let's see. Is there anything else we can do to factor this? Let's keep trying. This last one's a quadratic. It's tempting. Maybe I could factor that some more. Let's see if I can. 3. Well, I see a 2x squared, actually. So it has to be a 2x and a x. That's going to start me off. Can't get 2x squared without a 2x and an x. And in the end, we got a -3. So these have to multiply by -3. I'm thinking if you put the, put the -3 here and the +1 there, I think it does factor. If you distribute that back out, you get 2x squared plus 2x minus 3x. That's a grand total of -x. So that works, and then -3. So the question was, what are the other factors? It looks like the other ones that were buried inside of this problem are 2x minus 3 and x plus 1. So find the remaining factors of the polynomial. There they are, 2x minus 3 and x plus 1. Let's try this check right here. 3x cubed. Let's try this one out. 3x cubed plus 10x squared minus 27x minus 10. Ew. Ew. Look at that thing. That's gross. Not many things we can do. It's got nothing to start with, does it? It's like the last one it gave us x plus 8. That was a good starting point. X plus 8 goes into it. So we go graph the stupid or divide the thing. We're good. Here's the strategy. Ready? Any problem like this, you got nothing to start with. Nothing. I want you to go graph it. Get your calculator out and go graph this thing. This will be how we start a problem like this. We got nothing to go on. I don't know what goes into this. Go graph it and find any zero. Find a nice clean spot where it crosses the x-axis. Any clean number will do. I'm not factoring that. Grouping ain't going to work. I thought about that too, but that's the point of the lesson anyway, is go graph it. Yeah, they don't. I know. Find any spot it crosses the x-axis, anywhere at all. Could be 3 spots. I just need 1. 2. Okay, we got to vote for 2. Would you all agree it definitely crosses at 2? Okay, so you have some, I don't know what your graph looks like. It looks wiggles or so. I don't know. It crosses right here at 2. We all agree with that? Something like this? Okay. Here's the other big idea. Ready? If 2 is a 0, then I know something that goes into it. If 2 is a 0, then x minus 2 is a factor. This is going to be a big theme of mine later on in the lesson also. If 2 is a 0, then I do know something that goes into this thing. X minus 2. You know what's x minus 2? Because when you plug in 2, you get 0. That's the whole point. If it makes it equal to 0, then there must be an x minus 2 in here, because when you plug 2 in, 2 minus 2 is 0. That's the other big theme today. So if you know a 0, you also know a factor that goes into it. What if it crossed at 7? Could you tell me a factor that would go into it then? X minus 7, right? What if it crossed at -4? X plus 4 would go into it. That is huge. That's how you're going to start every dang problem. You got nothing to go off of? Go graph it, find a 0, and now you have a factor. So now we know that x minus 2 goes into this thing. So officially, we can start factoring this as an x minus 2 times something. I know this is going to be x minus 2 times something. I don't know what the something is. But darn it, I know that 2 makes it 0. So x minus 2 must be a factor. And how do you find the other missing stuff? Well, if this thing times x minus 2 is the cubic, then the cubic divided by x minus 2 is the missing thing. So you're always going to go to long division next. After you get a factor, this is why I harped on long division so darn much. You know x minus 2 goes into it, you divide it by x minus 2, and you're going to see what else goes into it. And I won't walk you through every little boring step of the long division. That's not really the point. So I'll go relatively quick on the work of that. 3x squared goes into that. Multiply through by it. Subtract some stuff. You get 16x squared. I guess 16x goes into that. Bring down your other junk. So you go subtract all that. You get your remainder of 5x minus 10. 5 goes into that. Plus 5. And look at the, and you should see every single time from now on, if you're doing this right, your remainder should be 0. Because you're claiming that x minus 2 goes into this thing. If it goes into it evenly, your remainder should be 0. So in practice, all your remainders should be 0. And now we know that when we divide by x minus 2, this was the other stuff that went into it. So this factors into 3x squared plus 16x plus 5. That's how I factor things. I graph it, I find a 0, I know a factor, I do long division, and I get out an answer, and I keep whittling it down from there. That is the big idea for today. All right, so we look at this thing, and let's try to solve this. Well, this one's pretty obvious. This one has a 0 and x's, 2. The other one's a jerk. I could try to factor it more. I bet it does factor. Probably factor to 3x and some x thing or something like that. Or, I just take the thought out of it. Just use quadratic formula. If it's too complicated, don't sit there and try to factor it all day. Just use quadratic formula. That's the point of it. Try to find when this is 0. Well, that's what quadratic formula is good for. So I'm going to use quadratic formula because I'm lazy. Negative b plus or minus the square root of b squared. So I got to figure out what 16 squared is. Had that in my calculator. It turns out to be 256. Minus 4 times a times c all over 2a. And a was 3. You go clean up this discriminant, and it turns out to be 196 when you do the 256 minus the 4 times the 3 times 5. And the square root of 196 is pretty. It's actually a nice, clean number. It's just 14. So since we have a nice, clean number, we can keep going with this thing. Let's actually do the plus and the minus version, see what we get. When we do the plus, negative 16 plus 14. What's negative 16 plus 14, guys? Negative 16 plus 14 is negative 2, right? Negative 2 divided by 6 reduces to negative 1/3. So there's one answer. Similarly, if we do the minus version, negative 16 minus 14 is negative 30. And negative 30 divided by 6 is negative 5. So there's all 3 answers for that. Took a little bit of work, but we got there. Notice we didn't have to turn to any of our tricks. We didn't have to do any difference of cubes or squares or grouping or anything weird like that. This takes all the thought out of it. If you can graph it and find a clean 0, then you found a clean factor, and you can do long division to figure out what the other factors are. That is the big, big theme for today. All right, let's look at some others. Can't do enough of these. So summarizing everything I just said, kind of here's your slide. You might want to write it down, because this says all those steps I just went through informally in one technique right here. So in general, how do you solve a polynomial equation? I give you some big polynomial. You don't know what to start. You don't want to do difference of cubes. You don't want to do any of that old stuff. It didn't make sense when you did it. And those techniques don't always work. This will always work if you can. And the first step is always to graph it. It's kind of a cop-out thing, but you need something to go on. If I give you a big 6th-degree equation and I say factor it, and I don't have a calculator, I can't do it. Nobody can do it. Just by staring at it, it's not going to have the answer. So you graph it and find as many exact zeros, spots where it crosses the x-axis, as you can. Exact. That word is capitalized for a reason. If you don't know what the number is, don't use it. If it crosses the axis at 1.42 and you don't know what that is, don't use it. If it crosses at 1.142857 and you don't know what that is, don't use it. Use a number you're 100% sure you know what it means. If it crosses at 3, great. 3 is 3. I can use 3. Crosses at -6, great. Make sure you use a number, a clean number that you know. Number 2 is the big one. If you find a 0, say the number is 7, then x minus 7 is a factor. That's what we just went over. If 20 is a 0, then x minus 20 is a factor. If -8 is a 0, then x minus -8, better known as x plus 8, would be a factor. So for any 0 you find, say s, you find a number s, and that's where it crosses the x-axis, then x minus s will be a factor. If you've got lots of factors, you want to kind of distribute them out into one thing and do some long division on it. We'll do some examples of that later on, where you find more than one thing that goes into it. But essentially, you're going to do long division, and every time you do long division, you get depressed polynomial. And that's that vocab term from earlier, where the degree goes down by 1. Every time you do long division, the degree of your problem goes down by 1, and it gets easier and easier to solve. And eventually, you can whittle it down to quadratics and linears like you know how to do, which is the whole point. Clearly, that should be number 4 on the slide, not 3 again. But you just keep doing it. No matter how big it gets, it'll be the same procedures over and over and over. So there's a lot of talking in those today. We're really just trying to get the procedure down of how you're going to solve these things. We're going to follow these steps religiously to solve any problem from now on. And again, on a test, I don't plan on giving you anything too exotic, anything with A's and B's or X's and Y's or anything weird like that. So pretty much just be X's and numbers. If it's just X's and numbers, you can always fall back on this technique to solve it. So try to remember the things from the last unit. They are useful. But if you're in a jam, this will always work. And let's do this one. So I got 3 examples. We'll do those and we'll call it a day. Example number 1, x cubed minus 6x squared minus 3x plus 18. So you got lots of techniques to do this. You could actually factor this by grouping, but we're not going to do that. We're going to practice, pretend we don't know anything. So what do you do? What do you start off by doing? Grab it. Go grab it. Let's go grab it. Find me something. Find me at least one spot where it crosses the axis. At least. Got to vote for 6? Okay. Got to vote for 6. Anybody want to confirm 6? So on your test, I'd probably have a section over there that says zeros. And right off the bat, if you just found one where it crosses the axis, that's what a 0 is, 6, and you're good. So in the slot that says zeros, you know you put 6. But you want 3 answers, right? You're not done until you got 3. So automatically, what's a factor that goes into this? If 6 is a 0, what's a factor? X minus 6. So x minus 6 goes into this. So right away, I can start factoring this into x minus 6 times something else. I don't know what. That's what the long division is for. I will take the original problem, x cubed minus 6x squared minus 3x plus 18. And since I know x minus 6 goes into it, I'll divide by x minus 6 to see what else goes into it. By the way, this is also a way to check yourself. If you do this long division, you get a remainder of 0 out, as you should, then this definitely went into it. You're on the right track. So let's see if we can get a remainder of 0 out. Here we go. Well, x squared goes up there. And that gives me an x cubed minus 6x squared. Now, these two things are identical. You got an x cubed minus 6x squared on the first line. You got an x cubed minus 6x squared on the second line. So when you subtract them, there's a remainder of nothing. They're gone. But you still have this other stuff over here, this negative 3x plus 18 you haven't dealt with. So just like before, it has to come down, and you got to go again. And I'm thinking x times negative 3 would work, right? So negative 3 times this is negative 3x plus 18. And you see they're the exact same thing, and your remainder is 0. So at this stage of the problem, you're 1,000% confident you're doing it right. I claimed 6 was a 0. That means x minus 6 should go into this. And it sure as heck does, because anything divided by anything, the remainder is 0. Yes, it went into it. So what's left? Well, x squared minus 3. So this factors down into x minus 6 and x squared minus 3. That's my procedure. So long division was like an intermediate stage, just to get the other factor there. Now, what makes them 0? Well, we already said this one. This is obviously 6 because that's where we got it from, right? We looked on the graph. We already got the answer of 6. And we went back and said x minus 6 is a factor, so obviously 6 is a 0. And there's 2 buried in here. If you set this equal to 0, move the 3 over, take a square root. Don't forget your plus or minus. There's the other 2. So on the test where it says zeros, you should write down 6, but you should also write down plus or minus square root of 3, because there's my 3 answers. And don't tell me some decimal version of square root of 3. I bet you it crossed the axis at 2 other spots, right? What did it say, like 1.73 or something like that? Don't use that, because 1.73 is about the square root of 3, but not exactly to it. And that's your procedure. Over and over and over. Let's try number 2. Got another example of that, 3 of them. So this here, x to the 4th, minus 19x squared plus 48 equals 0. Here's example number 2. Now this is a quadratic form. I could pull out factoring techniques from the last unit. I could factor this thing. Probably would be easier than going the route we're trying today, but we're practicing this. And again, if you didn't see this as a quadratic form, it's okay. Go graph it. Use the techniques we're talking about today. Find me as many reliable zeros as you can. I need at least 2. Every time you get me a 0, I can depress this polynomial by 1 degree. So if you give me 1 0, I can get this down from a 4th degree to a 3rd degree. That's not good enough. We need to get down to a 2nd degree or a quadratic. So I need at least 2. Anybody got 2? All right, those are clean ones. Cool. So negative 4 goes into it and 4 goes into it apparently. All right, works for me. Well, let's see what else goes into it then. Okay, what's the main theme? If negative 4 is a 0, then x plus 4 must go into that. Do you buy that? And if positive 4 is a 0, then x minus 4 must go into this. So this has 2 factors in it. We got 2 zeros. That's great. There's 2 things I got. So here's your options. I'm going to give you 2 options, right? You can take the original one, divide by one of them, get out an answer. That's fine. And then you can take the answer and divide that by the other one and get another answer. That's fine. It's kind of like me saying to do this. hey, I want you to divide 12 by 2, and then I want you to take that answer and divide by 3. You could do that, right? You could take it divide by 2 first, right? Do some work. What is that? 12 divided by 2. 6. Figure it out. Then you could take it and divide by 3 again. You could get 2. That's fine. Nothing wrong with that. Or, if you're dividing by 2 and you're dividing by 3, could you divide by 2 and 3 at the same time? What's 2 times 3? It's 6. Could I just do 12 divided by 6? Yes, I could. So what's faster? Dividing by 1, doing some work, and then dividing by another? Or just multiplying these together in the first place and dividing by both of them at the same time? The answer is divided by both at the same time. So here's what we're going to do first. You ever have more than one factor? What I want you to do before you do long division is I want you to distribute them out. What is x plus 4 times x minus 4? If you went and distribute this out, you get x times x, which is x squared, right? You get x times negative 4, which is negative 4x. But then in the next term, you'd have a positive 4x, so they'd cancel. And then when you do the 4 times negative 4, would be negative 16. So these two together are the same thing as x squared minus 16. Does that make sense? So why divide by 1 and then divide by the other? I can divide by both at the same time. Dividing by both would be the same thing as dividing by x squared minus 16. So that's exactly what you're going to do. You're going to take your original thing and divide by x squared minus 16 and divide by both of them at the same time, and then life will be so far much easier. All right, we're doing some long division. So we're taking the original one, dividing by x squared minus 16. I see missing terms, so I'm going to put some 0 placeholders in here. So x to the 4th plus 0x cubed minus 19x squared plus 0x and plus 48. So just write out the whole thing again with some zeros, just so I have some organization. I'm dividing by x squared minus 16. So that one has a missing term in the middle also. There has no x's, so I'm going to put a 0 in for that too. Anything in the middle that's missing, good to have zeros in it. And then you go do your long division. So x squared times x squared would give me x to the 4th. When you multiply it by this whole thing, you get x to the 4th. X squared times 0x would be 0x cubed. And x squared times negative 16 would be negative 16 x squared. And then you do the subtraction. Okay, those are gone, those are gone. That turns into a negative 3x squared when you do the subtraction. And then if you bring down the other junk, you got no x's and a 48 still hanging out right there. Then you try to go again. So x squared times negative 3 would be negative 3x squared. And when you distribute it all out, it actually turns into something that makes perfect sense. The same thing we had on the line before. And when you subtract them, the remainder is 0, which means that it's working. So the moral of the story here is what? If you have to divide by more than one thing, don't divide by one and then divide by the other one again. Multiply them together and divide by both at the same time. So what's left over after I divide by these two things? X squared minus 3 is left over after I divide by these things. So all that work just to get that missing thing right there. That was like 90% of our work was just to get that missing thing. And then you can probably spot what the zeros are. These two are obvious. You got these from the problem, right? Negative 4 is a 0, 4 is a 0. The other two buried in here, again, if you set this equal to 0, move junk around and take a square root. And don't forget your plus or minus. There's the other two. Positive square root of 3 and negative square root of 3. So as promised, this was a 4th degree problem. It has 4 answers, and there they are. 2 of them you got for free by looking at the graph, negative 4 and 4. And they allowed you to do some long division and figure out what else is buried in there to get the other 2, which are plus or minus square root of 3. All right, one last one for good measure. Right down that bottom one, x to the 5th. Ooh, it's a 5th degree. That means I should have 5 zeros. There will be 5 answers for this. That's the big theme here. This technique's a little bit of a hassle. You got to graph something, and you got to know a factor, it goes into it. Then you got to do the long division. And then when you're done, you're still not done, because whatever is left over, you got to work on figuring out where that's 0. So it's a bit of a hassle, but it works all the time. This is always going to work. If you got answers, if you can find answers, dang it, this technique will get them. And you see we're doing 5th degrees and 3rd degrees and 4th degrees and whatever the heck they might throw at you. This will always work. So start the same way. Should be graphing it by now. I need at least 3 clean answers. The reason I know there's 3 because every one you get me will bring it down a degree. And I need to get down to a quadratic. I have quadratic formulas. I can't deal with cubics. I can't deal with fourths or fifths. So if you give me 3, I can get down 1, 2, 3 degrees to a 2nd degree. And I bet you it crosses at 3 clean spots. You might really have to change your window around on these two, by the way. If you really want to see the shape of the graph. You don't have to see the whole graph. You're just looking for where it crosses the axis. But if you want a big picture of it, you might have to change your window. Getting caught up today. I grade 10 problems for them.
There's one of them that they all, every degree of them, they all haven't done it, but it's only, I don't know if they should think because they don't know.
Might be an error with the key. Yeah. Okay, cool. Yeah. Agreed. And then, no, what is it? Whoa, flood of them. -8. 2. 1. 5. And you guys are sure. Okay, because we're going to do a whole bunch of work based on that. If you're not right, then all the work's going to be wrong. You don't want that, do you? All right, looks good to me. So let's review. If -8 is 0, what's a factor? X plus 8, would you agree? If 2 is a 0, then X minus 2 goes into this thing. And if 5 is a 0, then X minus 5 also goes into this thing. So there's some weird thing left over. I don't know what it is. How am I going to figure it out? I'm going to take the original thing and divide by all 3 of these. Now this sucks. I'm not dividing by 3 things. I'm going to take the time. I'm going to turn this all into one thing and then take the original, divide by that. So we're going to do some side work. What is all 3 of these multiplied together? Well, let's figure it out. Oh, bogus. We'll finish that up tomorrow. You can start on your homework. It's basically just this. This is the one big skill I want you to get down this week. Whole week is dedicated to this concept. Finish up the examples tomorrow. Have a good day.
I meant that with these because I want to see on 36 if that was